All right, folks, today we're going to be talking about water sensors. But before we get into today's episode, we're going to talk about today's sponsor, and that's Mouser Electronics. Now, folks, you know if you've been rocking with us for a while, that Mouser is one of the world's biggest electronic suppliers. And one of the cool things about that is that they know a lot about what's going on in academia and in industry. And sometimes they talk about it. Sometimes they write about it. Well, it just so happens that they wrote something incredibly relevant to today's episode, which is about how good neighbors can help their neighbors via Amazon Sidewalk. Now, Dan, do you know what Amazon Sidewalk is?
Only very loosely, because my Amazon Echo always asks me to sign up for it. But my guess is like it's the, I guess it's an internet.
Okay.
An internet
Expand.
of smart devices developed by Amazon, designed to create kind of a network of safety within your community. So if it uses other local devices also developed by Amazon to provide connectivity to the other networking devices in your neighbor's house and outside your home, to do things like, I don't know, safety?
You're kind of spot on. So
this is all I've gathered from push notifications that I swipe back up to the top, telling me to sign back up.
Look at that. Amazon's also informing you. They're educating.
Yeah.
What's not to love about the Bezos company? But that's besides the point. As you said, Sidewalk, kind of like the internet, it's a protocol. It actually, funny enough, carries off of a portion of the bandwidth of your home's Wi-Fi to do the talking it does with the rest of the devices in the vicinity. The reason this is interesting is because it allows you, smart homes have been all the craze. Smart lights, and then automations within your home when you walk in, lights out, whatever. But this gives you another layer of automation and awareness outside of your home. And to kind of, all of that sounds amazing, but I need some example to grab onto about why this would be interesting. Well, that's exactly what Mouser has provided today. They built this scenario. They're like, imagine that there was a water detection system in your neighborhood. And imagine it's kind of carrying off of your Wi-Fi and your neighbor's Wi-Fi and all of that. And for some reason, it triggers in your house. Let's say there's a flood, and the flood is so bad that it actually cuts off all electricity, so that if you had a sensor in your home, you probably couldn't get any notifications about it. Because Sidewalk is also carrying off of your neighbor's network, it can then hop onto them and be like, hey, by the way, something's going really, really bad. You're going to want to come home or call the fire department or something because something is flooding. That's like the image they've painted here about the potential of this technology, and they tied it in with, the world of IoT. But they don't just stop there, because like we said, Mouser is one of the world's biggest electronic suppliers. And they go through and give you a bill of materials for everything you need to make that happen. And they sell it all on Mouser.
Yeah.
And they don't just stop there. They don't stop there, folks. No. They write down the programming, the SDK, everything you need access to make this a reality. So if you're interested in this technology, if IoT is interesting, if you're like Daniel and Amazon just keeps annoying you about Sidewalk and you want to know what's good, well, Mouser's the one-stop solution. You get to learn about the technology, why it's cool. And if you're a maker like we are, you get a nice little weekend project out of it.
Well, that's what I was going to say. Is as an engineer, I feel like Mouser is already one of my favorite places just to go get the components.
Yeah.
But they've gone a step further now. Yeah, I get the technical resources. I get the inspiration for someone like me who sucks at coding. They even give me the code. I don't know. It just goes to show why we love Mouser, and obviously why we're so happy to partner with them, because we're actually excited about what they do.
Absolutely. And with that said, let's get into today's topic, which is, again, also about water sensors. A different type of water sensor, but still a water sensor.
Well, I think it helps to start by zooming out and asking the question, do you know if you're drinking water at your house is safe?
No, I assume it is.
And I do too, right? But I recently saw a post from one of my friends on LinkedIn saying, like, go to this EWG tap water database, look up the zip code you're in.
Yeah.
And, I've just assumed that my tap water's safe. And it's talking about all these different contaminants that are, some of them over 500 times higher than the health guidelines. Some of them don't have legal limits. And some of these things cause things like cancer. Some of these things cause things like brain damage. And so there's a lot of these chemicals in our water.
In our zip code?
Yeah.
Oh my God.
Which is crazy, right? And it obviously leads you to believe, how come I don't know this at my own house? How come I can't measure this at my own house in an affordable way and in an accurate way? Why do I have to go to ewg.org and type in my zip code to find this out, right? I think this is a relatable problem, not just for the contaminants that I saw for our zip code where we live,
Yeah.
but also, lead contamination mainly is one of these big contaminants in the world. It's a global issue. I think that they say the estimates are that at least 240 million people worldwide have lead levels in their water that lead to severe health problems, including brain damage, birth defects, neurological, and cardiac issues. And on top of all that, there's like 10 million households just in the US that use lead pipes for their drinking water, which is like just crazy for me to wrap my head around. And, I was freaking out about on EWG, these contaminants like bromidichloromethane.
I don't even know what that is.
I don't even know what that is, but chloroform, I know what that is.
Bad.
But those are actually measurable and those are in this database. But with something that affects so many people, it's crazy to me. We don't have better lead testing methods. They're really expensive. They're really slow. And the worst part is like they usually just give binary yes, no results. They don't give you the actual concentration, which is kind of what you need to know to understand your risk level for your drinking water at your house or at your school or at work, etc.
Yeah, and the statistics you shared just kind of shed some light on what a big concern like clean water is. But in terms of lead, I think one of the most surprising things to me is that it's estimated that lead causes approximately 1 million deaths every single year. And that's like totally preventable, right? But we know lead pipes are bad. We know lead contaminated water is bad. And just having kits that can properly test for it would probably prevent a lot of these deaths. But like you're saying, it's just not the case because the good tests require heavy, expensive machinery and days to get results back, which is just not feasible at scale. And the easy to use tests are just a binary yes, no that give you no idea about the concentration of it. And it could be, it's that they even give you a yes or no on the border and they have some sort of inaccuracy. So now you're kind of risking it on the yes or no.
And a lot of those like really binary, cheap, easy to use, quick tests they aren't sensitive enough to detect lead at the levels that, around the threshold of what we say is safe versus unsafe. The threshold that the EPA regulations require, the Environmental Protection Agency here in the US, is that lead levels in drinking water have to be below 15 parts per billion. So that's an important number to remember, 15 parts per billion. Most of these current detection methods struggle with such low concentrations. The only way to do that is to take a sample, send it to a lab. It takes a number of days to get results back, and it's pretty expensive. That's why this equipment only exists in a lab. So I'm assuming that's how they get results on something like EWG, right? They take samples, they send it to a lab, and they test it, and then the results end up posted there. But how do you know house versus house, drinking tap versus drinking tap, where there are issues and where there aren't?
And we're fortunate to have access to these results to even begin with, right? Like, yeah, it would be nice if all the water we were getting was clean, but at least we can go somewhere that gives us this sort of feedback. I'm assuming that's not the case in the rest of the world, right? Especially places that already struggle with access to clean water.
Exactly. So what this team has done, and it's a awesome joint research between MIT Nanyang Technical University, which I think is in Singapore.
Yeah.
And a number of different private companies as well have partnered to create this chip-based detector. So it's small, it's on a microchip. It can measure lead concentrations as low as 1 part per billion. So remember the threshold we wanted to detect was at 15 parts per billion. It goes well below that, and it's 15 times lower than that. Can detect concentrations as low as 1 part per billion. And the big headline here is they do it and they can manufacture the sensor in a way that's cheap, affordable, and easy to scale, which obviously is one of the constraints right now with these lead detection methods that we have, because they're expensive or they don't work that well or they don't scale that well and they can only sit in a laboratory. This team from MIT and from Nanyang University have seemed to crack the code.
How did they crack the code? Because that is the thing that we're all about here, right? That the secret sauce. As far as I understood it from this article, it kind of, I'm going to be honest, bit technical. It got into the weeds for me, but I'm going to try to sum it up. So you have these folks that have apparently been just chugging away at this work for a couple of years now. Like this wasn't a 1-year problem. And at its core, let's say their tomato base of their amazing secret sauce is a photonic chip. So it's a chip that is processing light signals. And what was so difficult for the longest time is that there's this molecule arrangement that they were trying to embed to the surface of this chip so that it could bind well to lead ions, and that's how they wanted to do the detection. I guess they couldn't figure out how to make that formation happen on the surface of the chip, but they finally settled in on this Fischer esterification. I don't even know if I said that right. I think I did. But it's a chemical process that results that requires you to mix like an alcohol with another, like an acidic solvent or something, and then it generates that crown. What is it?
Crown ethers.
Crown ethers.
But essentially, right? This a lot also went over my head.
Okay.
But
I wasn't alone.
What we need to boil this down to is, this photonic technology, which uses light to perform measurements and do calculations. This has existed not for a long time, but for a little while. It's quite on the cutting edge of innovative technology in terms of signal processing. But one of the challenges they had was figuring out how to capture lead ions. So how do we pool lead out of a droplet of water that we put into this testing system to detect how much lead there is in the entire portion of water, from the sample. So what they did is they figured out how to add these ring-shaped molecules that attract and capture lead ions on the surface. They also have a microfluidic chamber that kind of transports these water droplet samples inside into the optical fibers, and then there's these crown-shaped or ring-shaped molecules that capture lead ions, and then it passes light signals through, and it's basically able to achieve high accuracy in detecting how much lead there is based on the differences in the light signals when there are high lead concentrations and when there are low lead concentrations.
That makes sense. And another thing that I thought was interesting is that, again, these tests that we're talking about that were easy to do, not only did they not have the right detection limit, but they had a lot of inaccuracy associated with them. At a significantly lower detection limit than what the EPA even requires, these folks are reporting an accuracy within 4% of the reading. So that's even like another layer of, wow, that's really impressive. I can't believe they pulled this off.
Well, essentially with that level of accuracy and that level of precision that they have down to the parts per billion, you can trust the measurement that comes out of this, especially in regards to the 15 parts per billion threshold that they're trying to target. One of the things that I also thought was interesting is they're able to still achieve this high level of accuracy across a range of different water acidities. So from pH 6 to pH 8, they saw really stable measurements. And then also with different water types. So they're able to do it with seawater and with tap water, which, I don't know this firsthand, but I'm assuming given that they noted this as part of the research, that was one of the constraints with the existing test methods as well as, maybe you might get a false positive or a false negative or no result, depending on if you had super acidic water or super alkalinic water, or maybe it had too much salt in it for you to be able to get the proper lead readings.
Right. And another thing that I think is worth noting is that their focus was obviously on lead this time around because of all the things we talked about at the beginning, the impact it can have on the world. But apparently this solution can actually be modified to target different metals as well, like cadmium, copper, lithium, cesium, radium. So it's not just a lead-focused solution. It's kind of like a platform for detecting these contaminants within water. So not one of the participants of this research, but someone in the industry actually made a note of saying that this could be really useful for facilities that are manufacturing batteries, for example, with their wastewater assessment, because most folks probably won't take that on because of how expensive it is. But if it's something that a technician can go out and keep monitoring it on a regular basis, then they're more likely to make sure that the level of contaminants they're releasing into the wild is actually quite low.
Well, I agree, right? It allows you to do widespread monitoring. It allows you to do ongoing water quality monitoring as opposed to taking a sample and sending it to a lab.
Right.
And it also allows, they're saying, untrained personnel to be able to do this pretty accurately as well. So it doesn't require you to, put on your goggles and your lab coat and go do a bunch of processes in the lab. They're saying you just put a drop of water on this thing, the cartridge sucks the water in, and then the photonic system detects on its own how much lead there is in there. And like you said, based on this crown ether process, which they said are like the specialized rings that grab onto lead ions, they were also able to specialize this to grab onto things like cadmium, copper, lithium, radium, and those are some of the other heavy metals that I think, like you said, for example, industrial battery processing plants might be interested in detecting, and honestly, legally probably should be detecting, and this will allow them to measure that more frequently. It will allow folks without a technical background to do that. And one of the things that they also mentioned that they're working on, and they said it might take 2 or 3 years to get there, is to make this into like a practical handheld device that you can use for on-site testing. They said they need to do some mechanical work to package the chip with a smaller laser, and then optimize the full mechanical, optical, chemical design to get this thing to fit onto a small, cheap device. But they say once they can do that, it can make lead testing and, again, all these other contaminant testing way more accessible, way more affordable. And in this case, especially in developing countries, like you were saying, where they may not have access to be doing even sporadic lab testing to get the accurate measurements on how many of these contaminants there are.
I mean, dude, even in Flint, Michigan, right? Like, it's been years now and they still have contaminated water. But yeah, that's the most amazing part out of all this to me. You know, we talk about it all the time on this podcast, but it's great to see these incredible achievements happen in the lab. But now we're seeing folks that are telling us, hey, this isn't just a lab thing. We are thinking about making it a product, making it available to the public in 2 to 3 years. And the hardest part is already accomplished. We're just trying to figure out how to productize this the right way.
And not only that, right? It's not a problem that only affects one person every single year, right? You said there are at least 1 million people dying every year because of lead poisoning.
Right.
And we know that at least 240 million other people are exposed to unhealthy levels of lead through their drinking water. So this is something that we can do to help do preventative measurements, right, at industrial plants to make sure that industrial wastewater is being constantly monitored to make sure that more contaminants don't make it into our drinking system. And then obviously go around and diagnose and solve issues where there is contaminants in the drinking water and give people the power, basically democratize the power to be able to test your water and say, no, this isn't safe. I shouldn't be drinking
That's
this.
a nice snippet. Democratize it. I like that.
I don't know about that, but...
No, I'm a fan. But yeah, I think that's the gist of it. You want me to do a quick wrap up?
Yeah, please do.
All right, folks, do you know what's in the water that you're drinking at home? Odds are you don't really. In fact, there's about 240 million people in the world that are exposed to lead contaminated water. And this is horrible for brain development. It can cause birth defects. It can cause neurological issues, cardiac, and other damaging effects. Still, in the United States, 10 million households are getting their water through lead pipes. Now, the difficult thing is that you can't even test for the lead that is in your water effectively because the tests that are readily available are not very accurate, and the ones that are good are incredibly expensive and take a lot of time. But does that mean you should just give up and drink bottled water? Well, no. MIT and Nanyang University are trying to come up with this solution that is going to be both great and inexpensive. And the best part of that all is that they've already accomplished it. They're using photonic chips, which is light power chips that can analyze data coming in through a proprietary sensor that has taken them years to develop, which bind to the lead ions in the water and tell you within a 1 part per billion concentration if there is lead in your water, which is, by the way, 15 times better than what the EPA recommends. So that is why you do not have to worry about the lead that is potentially in your water in the coming years.
I'm with you, man. You nailed it.
I try. What can I say? Now, before we wrap this up, I believe we owe a thank you and a meal to a certain group of fans in a certain country. Is that right?
Yeah, we were a top 25 podcast in Thailand.
Where's the buzzer when you need it?
And appreciate our friends in Thailand, and we appreciate your food. So
I
we
love
will
Thai food.
definitely use this as an excuse to go enjoy some Thai food together. But
Yes.
I do have to say Kap Kun, which means thank you in Thai, to appreciate all our friends in Thailand who are listening to us, rocking with us. And I will say to all of our friends in Thailand and outside of Thailand, we've got some interesting news to share as well, which is that we've launched a newsletter. So we've taken the last 3 years, every single Tuesday of publishing an episode. We haven't missed one, by the way, for over 3 years of digesting interesting and impactful technology and delivering it to you in short, bite-sized podcast episodes that are easy to understand. And we're going to try and take those same skills that we've developed from podcasting and create an awesome, interesting newsletter that takes impactful technology and digests it into small bits that are easy to understand. So we hope that we're not starting from zero there, but we would appreciate a little bit of your flexibility with us and give us some slack while we get this up and going. But we want to appreciate everyone who joins now. We can consider you to be a co-founder, a founding reader of our early newsletter. So we'd appreciate if you check out the link. It's in our show notes and go sign up. You can also go to the read.thenextbite.com and sign up. It'll only take you a couple seconds to enter your email in there, and we hope it pays off tons of dividends when you read this newsletter and you're like, man, now I can get awesome tech in my email inbox as well.
Yeah. Yeah. I mean, I could not have said that better. So with that said, thank you folks for listening. And as always, we'll catch you in the next one.
Peace.